I received a delivery of a 19th century clock bell, the kind you might find on a European 30-hour duration tallcase or longcase clock. And I could immediately see the bell was an unusual dark colour and had evidence of a previous repair. And when we sound the bell, we can hear that it is cracked and has very little, if any, ringing tone. The crack runs from the edge of the bell and then veers across and then back down towards the rim again. There's another mark on the surface of the bell which I presume is to do with some earlier attempt at a repair. The crack also forks with another limb terminating in this area of corrosion. On the inside we can see the previous repair, which is hard soldered, which is fine, and some scratching as well. The crack again veers off. When we flex the rim of the bell, we can see that the crack is quite extensive, and testing with our brass hammer, in the clock it would be iron or steel, it doesn't really matter where you hit the thing, as it is of little use. So the three principles for soldering is you have to have somewhere for the solder to go, which is what I'm doing here. The surfaces to be mated must be clean and the temperature must be suitable for the solder to flow. So I create a V-shaped channel using this 3-square file with 2 safe edges. Now I made a decision not to chase the crack all the way on the outside of the bell because I didn't want the outside to be covered with solder, which may be a mistake. But on the inside I used a tungsten carbide graver or engraving tool to slowly chase the crack, creating that V-shaped channel along which the solder will flow and will create the mating surfaces. I'm going to bind the bell in iron binding wire. This is to give it a bit of stability during soldering. I don't quite know how far the crack extends, and the melting point of the silver solder is reasonably close to the melting point of the bell. The bell will have to get glowing red or orange in order for the solder to work. So this wire, which I twist up using my trusty hand drill, will just give it a bit of support. So just tension the wire a little bit using my parallel jawed pliers, which are incredibly useful for this kind of work. And the same on the outside as well. Not really sure whether this binding was necessary, but it kind of gives a bit more confidence to the whole soldering operation. There we are. So for our solder to work, we need some flux. Flux has got two functions. One is to reduce the surface tension of the solder so it can flow, and the other one is to keep air or oxygen away from the joint to prevent it from oxidizing. The joint, as I said, must be clean. I'm using tenacity flux, which is a relatively high temperature bronze or silver soldering flux, which will withstand prolonged heating, and I don't and can't heat the bell too rapidly, so this flux is particularly useful for these kinds of applications. I also apply flux to the solder for the same reason, to prevent it from tarnishing, and the solder I'm using here is extra easy silver solder, so it's classified as a hard solder. I'm going to apply the solder directly from the stick. As I begin to heat the bell, you can see the water in the flux is beginning to bubble off, so it heats relatively gently and heating the general area of the bell so it all expands at the same kind of rate. Once the flux has gone clear or vitreous, then I apply the solder. You could do this by applying little chunks before you begin the heating, which would be a bit neater, but I wanted the extra flexibility of putting the solder exactly where I wanted it. You can see the bell is glowing orange. So I've soldered the whole length of the joint now, and all that remains is to allow the bell to cool, and we will see whether the repair has been successful or not. So off with the binding wire using the Nipex cutters, which are absolutely great for most workshops. You can see the remnants of the flux there, that kind of black vitreous layer, which is quite hard. And just testing with the brass hammer, we can hear that the ringing of the bell has been restored. These are not tuned musical bells, by the way, they're sand cast and as cast. So there's the joint, not too bad, and we don't know what the bell sounded like when it was new, but certainly that will give many years of service. So there we are, a video on repairing by silver soldering a 19th century clock bell. So I think there are two things that are worth noting here. One, of course, is that that technique of silver soldering forms part of a much wider gamut of joining techniques, such as soft soldering, the kind of thing you get in electronics, welding, of course, bonding with glues or cements, sewing, and so on. And all those techniques, whether you can actually do them or whether you have access to them in the sense that you know they exist, are incredibly useful in the whole sort of right to repair or sustainability model, because the more things or techniques you have, then the greater the chance there is that you'll be able to identify that something can be repaired and get it done. The second part of this is a question of whether it's worth it or not, and of course that entirely depends on the set of values you attribute to the thing and to the process of the repair. Yes, it's true, you could probably go to an online auction and buy a similar looking bell for less than it cost to buy the materials. But that's kind of not the point, really, if you consider the whole energy that it's taken to make that bell, from mining and refining the ores to casting, pattern making, distribution and so on. Then that's a slightly different perspective. And also that bell comes with a clock which is 200 years old, give or take, and I personally think the well-being of the repair from the clock's perspective and from my perspective, or the perspective of the practitioner, far outweighs the idea of the cost of replacing the bell. Anyway, to discuss, so whether it's something like this, what might be considered an historic object that we're repairing, or you are making something new, for instance, a steel bike frame might be silver soldered or brazed in exactly the same way. I hope this is useful and instructive, and importantly encourages people to consider repair as part of the future of objects. Thank you, and we will see you again soon.